Hello students, today is day number 2 of scientific notation. Okay, so please remember you do have a few things that are due. Make sure you get those turned in. The adding and subtracting mixed numbers, multiplying mixed numbers, dividing mixed numbers, and then the stuff that we've done this week, the calculator activity, and the comparing and ordering real numbers. And then today we're going to be looking at scientific notation, so you will have an assignment today. So let me switch to the big board, and now let's talk about scientific notation. Let's review what we discussed yesterday real quick. Okay, so yesterday we found out that scientific notation was just a way to make very large numbers or very small numbers easier to use. And that was the big benefit for scientific notation. We know that we write scientific notation as a product of two factors, where we have this first number called the mantissa. The second number is the number that moves our decimal around. It's the times 10 with an exponent. And the exponent we found out is going to be the number of places I move my decimal, not the number of zeros. Okay, so let's kind of review what we did. Yesterday we looked at how to change a large number into scientific notation and a scientific notation number with the positive exponent into a large number. We found out that all we do is we take the significant digits, the 184, we put a decimal in that such that the value of this number is between 1 and 10. Okay, so we have to make sure that that number, that mantissa, that number in front of the times 10, is a value that is greater than or equal to 1, but yet less than 10. Okay, so when we looked at this one right here, we took the 184, we placed the decimal between the 1 and the 8, because that makes this number have a value between 1 and 10. And then we write times 10, because that's what moves our decimal around. And then the 13 comes from, where did my decimal start? Where was it originally? Where did I move it to? It's the number of places in between. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that was our exponent. Okay, so we reviewed a few questions. We did a few questions yesterday, so I just want to review those real fast, and then we'll move into our lesson for today. So in this one, I asked you to write these standard numbers, these numbers that are written in standard notation, into scientific. So the way we do that is we first look at the significant digits. In this first number, we have a 45 as our significant digit. So I need to place a decimal in that number such that its value is between 1 and 10. So could the decimal go here? No. Could the decimal go here? Yes. Could the decimal go here? No. So the only place it can go is between the 4 and the 5. And then we write times 10. And now we need to figure out what's the exponent going to be. So I asked 3 questions. Question number 1, where was my decimal originally? Well, it was right here. Where did I move it to? I moved it to between the 4 and the 5. And then the third question, how many places in between? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So in this one, we had an exponent of 11. Okay, in the next number, we had 3 significant digits. So we write those down. We place a decimal such that its value is between 1 and 10. So could it go here? No. Could it go here? No. Could it go here? Yes. Could it go here? No. The only place it could go is right there. Okay, then we write times 10. And then we ask ourselves those same 3 questions again. Where was my decimal originally? Where did I move it to? How many places in between? 1, 2, 3, 4, 5, 6, 7, 8. So we would put an exponent of 8. So that is taking a number from standard notation and converting it to scientific notation. Now, what about the other direction? What if I give it to you in scientific and ask you to write standard? Well, we know that these 3 numbers right here are going to be my significant digits. So we're going to write 1, 3, and 4. Now, this times 10 to the 8th power tells me I'm going to move that decimal 8 places to the right. Because every time I multiply a number by 10, it's going to move the decimal to the right. We did an experiment in class yesterday that was like that. We took the 5 and we multiplied it by 10. Well, this 5, the decimal originally is right there. When I multiplied it by 10, it turned to a 50. So it took that decimal and moved it 1 place. Then I multiplied by 2 tens. So I'd take that 5 and then 5 times 2 tens, 10 times 10 gives me 500. So for each 10, it moved the decimal 1 place. So this one is like multiplying by 8 tens. So I'm going to move the decimal 8 places. So the first 2 places are actually the ones around the 3 and the 4. So how many more places do I need to move it? 6 more places. And that's the number of zeros that you add. Just like that. And then you throw in your commas. And you could put a decimal at the end if you chose to. Now, notice that that is a clean answer. There's 1 decimal in it. If you need to actually do these humpy bumpy things, do not do it on the answer that you're going to give me. Because if you have a decimal here and you have these little marks like this on your number, I will count that problem wrong because you have 2 decimal places in your answer. That tells me that you didn't know what you were doing. Okay, now this second one, we do the same thing. We take this 5.9 and we write it as 59. Okay, I look at this times 10 to the 5th, so that means I'm going to move my decimal 5 places. One of those places is around the 9, so I need to add 4 more zeros. So 1, 2, 3, 4, and then we come back and we add our commas. That's how we write a scientific number and translate it into standard notation. Now all of those are for big numbers. So today what we need to look at is, what if I have very small numbers? How does that change? Well, just like when we started, okay, I showed you an example of a scientific notation number. Well, here's another one. Here's a number written in standard form, and here's that same exact number written in scientific notation. Now, what do you notice about this? Okay, one, they look about the same, but here I have a negative exponent. So big numbers, okay, get positive exponents. Little bitty numbers get negative exponents. Now you may say, well, that's not a little bitty number, that's really long, but it's really, really small. I mean, if you think about this is tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, 10 millions, 100 millions, billions. So this is 45 billionths. So this would be like taking a dollar bill, chopping it into a billion pieces, and taking only 45 of those. Very, very small. Okay, so how do we do this? Well, we do it the same exact way. Okay, I need to look for my significant digits. Well, in this one right here, there are 2 significant digits. I write the 45 down. Again, that mantissa has to be a value or have a value between 1 and 10. So the only place it can go, the decimal, is right there. So we still ask those same 3 questions. Where was my decimal originally? Where did I move it to? And how many places are in between? 1, 2, 3, 4, 5, 6, 7, 8 places. And since it's a small number, that's why it's a negative 8. Okay, so let's see if we can do a couple of those. So take just a moment and write these numbers down for me. Okay, so let's see how you do. Okay, this is what you do. So the first thing in this first one is we're going to look for our significant digits. So that means we've got this 34. So I'm going to write that down. 34. Now I need to place a decimal in this number such that its value is between 1 and 10. So could it go here? No, because that's 34. Could it go here? Yes, because that's 3.4. Could it go here? 0.3. No, the only place it can go is right there. Then we still write times 10. We ask ourselves the 3 questions. Where was my decimal originally? And these are easier because there is one. Where did I move it to? Right there. Now, how many places are in between? 1, 2, 3, 4, 5, 6 places. Now, since that's a small number, a number less than 1, it's going to be a negative 6, just like that. Okay, now this next one, we have 3 significant digits. Okay, the 3, the 0, and the 7. Excuse me. Now this 0, it does become significant because it's between 2 counting numbers. So we're going to write it as 307 times 10. We'll go ahead and write that. Now that 307, again, I need to place a decimal in it such that its value is between 1 and 10. So could it go here? No, that's 307. Could it go here? No, that's 30. Could it go here? That's 3. Yes, it could. So there's my decimal place. So we ask ourselves the same 3 questions. Where was it originally? Where did I move it? How many places in between? And there's 3, but because it's a small number, a number less than 1, it is a negative 3. Now you do the last one by yourself. Let's see if you can figure this one out. Pause the video and answer that question. Okay, so let's see how you did. First, how many significant digits? Just one. Okay, so we just write that 9 down. Okay, now I could put a decimal right there or not, it's up to you. And then we write times 10. And now, what do we want to do? Okay, I want to ask those same 3 questions. Where was it originally? Where did I move it to? How many places in between? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, since it's a number less than 1, it becomes negative 10. And that's all there is to doing that. Okay, so that's how we take a standard notation number that's small, that's less than 1, and convert it into scientific notation. Notice it's the same process, it's just your exponent now has to be negative. Okay. Now what about going the other direction? What if I want to go the other way? Scientific to standard. So what we have to notice is that this negative exponent tells me I'm going to move the decimal the other direction. So if we were to go back and look at this kind of a question, when I was multiplying by 10, it was moving that decimal to the right. So I would move the decimal to the right. But now with a negative exponent, you're not multiplying by 10, you're actually dividing by 10. So instead of moving the decimal to the right, making it a big number, I'm going to move it to the left, making it a small number. So this time what we're going to do is we're going to come over here and we're going to take that 48 and write it down. Okay, now I know that I'm going to be moving my decimal because it's a negative exponent to the left. And it tells me I've got to move it 6 places. So if I got to move it 6 places, this makes it a little easier. You're always going to move it around one number and just one number. So how many zeros do I need to add? Well, if I move it around one number, that means I've got 5 left to go. So that means I'm going to add 5 zeros to the front. And then you also have to remember, in these numbers, you have to have that decimal there. Okay, so this number, 4.8 times 10 to the negative 6, will be this number in standard notation. So let's try another one. So 2.456. So I'm going to come write that down. 2, 4, 5, 6 without the decimal. Now I need to move the decimal. How many places? 4 places. And because it's negative, I'm going to move it to the left. Now I got to move it 1 place around that 2. So how many more do I have to go? Got to go 3 more. So 1, 2, 3, add a decimal, and there it is. Now you could add a leading 0 to each one of those if you wish, but I'm not going to take off points if you don't. Okay. Now you do this last one on your own. 9 times 10 to the negative 7. Now some of you may ask, well, where's the decimal in that 9? Remember, if you don't see a decimal, it's always at the end. Okay, so convert this into standard notation. Pause the video and do that. Okay, so let's find out how you did. Okay, so I'm going to write the 9 down. Okay, and that decimal's right here. Now I need to move that decimal 7 places to the left because it's negative. So there's 1 place around the 9. So how many extra zeros do I add? 6 of them. So 1, 2, 3, 4, 5, 6. Add a decimal, add a leading 0 if you want to. All right, so that is converting scientific notation with small numbers into standard form. Okay, so that's what we're doing basically in this particular lesson. Okay, so you've got 4 basic parts that you have to understand. How do I convert a big number into scientific notation? How do I convert scientific notation numbers into big standard numbers and be able to recognize that it's a big number versus a small number? And then write small numbers in scientific notation and write small numbers that were scientific and be able to recognize that it's a small number and know which way to move the decimal. Okay, so that's what we have to do there. Now there are some other things that we have to look at in terms of scientific notation. You know, do we actually use some of this stuff sometimes? Sometimes we do. So it says, did you know a regular pencil can draw a line 2,210,000 inches long before it runs out of lead? Wow. Well, could we write that in scientific notation? Well, this one, yes, we could. First, we look for our significant digits, the 221. Where will my decimal need to go in that? Between the 2 2's. And then we write times 10 to the. Now we ask ourselves the questions. Where was my decimal originally? Right here. If we don't see it, it's always at the end. where did I move it, and how many places did I move it? 6 places. So there would be that particular number in scientific notation. But there's one thing you got to remember. It's a word problem, so that means it has a label. And in this one, its label is inches. Okay? Now, let's do one more on this, and then we'll talk about one last thing. Top speed of some species of snails is 0.00036 miles per hour. Boy, they are cruising. Okay, what's that in scientific notation? Well, we take our significant digits, 36. I place my decimal in them, okay, because I need it to be as a value that is between 1 and 10. Then I write times 10 to the. Now I ask those questions. Where was my decimal originally? Where did I move it to? And how many places in between? Now, since this is a small number, I moved it 4 places, but it's going to be a -4. And then our label would be miles per hour, MPH. Okay? Now, there's one last thing that you have to be able to do with scientific notation on the STAR test. You've got to be able to recognize what kind of a number is in scientific notation. So if I give you these 2 numbers, it looks like they're written in scientific notation, but are they? Well, if you look at this one right here, the mantissa is not of a value between 1 and 10. So this looks like scientific notation, but it is not. Same thing for this second one. The mantissa is not in the right form. Okay, so it's got to be a value that is between 1 and 10. Okay, so let's see. We've got a list of scientific notation numbers here, what looks like to be scientific notation numbers. Where should they go? Okay, so this one right here, this first one, is it in scientific notation? No, it's not, because the mantissa is too big. What about this one? Is it good? Yes, it is. That one is correct because its value is between 1 and 10. What about this one right here? Yes, it is. That one is good. Same thing. Its value is between 1 and 10. What about this one here? Yes, it is. That one is a good scientific notation number. What about this one? Yes, it is. Scientific notation. What about this one? No, it's not, because its value is not between 1 and 10. And what about this one? No, it's not. Again, its value is not between 1 and 10. So you've got to be able to identify that. Okay, now what you're going to do on your assignment today is you're going to do some scientific notation practice. Okay, so you are going to do a form. So you're going to go to Google Classroom, click on the form. Okay, so let me show you what the form will look like. Okay, so the first thing you're going to do in this form is you're going to type in your first name, last name, select the appropriate period. Please make sure that you're choosing the right period. Okay, you know what class you have me. And this assignment is going to be divided into 4 sections. Okay, so you'll have to fill out the first section and then hit next. And then that's going to take you to the second section. Okay, the second section, I'm giving you numbers in scientific notation. Now, I had to write this a little differently because we don't have exponents in a form. Okay, so this right here is 10 to the second power. See that little, that's a little exponent key, just like we do on the calculator. So this says 2.54 times 10 to the second power. And I want you to write your answer right here in standard form. Okay, so you'll just type in the number. Okay, and then you'll do the same thing for the next one. Okay, and the next one is a negative exponent, so that tells you which way you've got to move your decimal. And you do that for the first 10 questions. Now the second 10 questions, once you get finished with that section, it'll take you to section 3. I'm going to give you a list of standard notation numbers, and I want you to give it to me in scientific notation. So that means I need it to be in this format. That's how you're going to type it. 5.6 space times space 10 exponent, and then whatever the exponent happens to be. Okay, so that's what you'll do on the next 10 questions. Okay, giving me the scientific notation. And then the last one, there's 2 questions about application. Number 21 there says Jupiter has about 778120000 kilometers, which is 778,120,000 kilometers from the sun. Okay, what is this distance in scientific notation? Don't forget your label. So you're going to take this number and convert it into scientific notation, and then place a label on it. Okay, and then the last question is a comparing. Oh, I messed up the "the" there. I got to retype that. It says the E. coli bacterium is about 5 times 10 to the negative 7 meters wide. A hair is about 1.7 times 10 to the negative 5 meters wide. Which is wider, the bacterium or the hair. So you have to select which one is correct. And that's what you're going to do for your assignment tonight. This one will be due by Sunday. And remember, we're going to have a test next week. Scientific notation will be on that test. So until tomorrow, I'll see you later.